Testing, testing. Welcome back. Continuing with this same project, Rhino 7 Education Lab, GH Basics Curve. This is actually going to be the second script. I should have changed that so you can track that to the GH file. As you can see up here, GH Basic Curve 002. Following the Rhino Menu Bar curves down to Cloud Point, we're going to take a look at creating Cloud Point, which I did above in the last video, which is the first part of this script, and then I've continued with some techniques of adding points and removing points in Grasshopper. The trick is you've got these very simple commands over here that you can follow and learn Rhino curve tools, which is the point of this education lab that I'm putting together with visuals and some playground scripts. And what I did before was I went in and I took a look at some creating point clouds from these different tools that are right up here in the Vector tab under Grids, and you come down to Populate 2D, Populate 3D, and Populate Geometry. Well, I did that in the last video, so what I want to do is continue with the adding and removing of points. The easiest way to do that is to gather up, say, these points and bring them both together in a merge tool. You can do that through another tool as well, but then you get into maintaining the data structure. And so Entwine is a tool that's actually pretty good for that as well, but I'm not going to use it currently in this situation, so I'll leave it off. A little relay here over to a list items, and then what I've done is I've found a list length, which is a number, so always be willing to use your panel tool up here to see what the number is. And then I just did a little division in my parameters to take that number 22 and divide it by whatever I did, and ended up with a 5.5, and then flattened it or lowered it down to an integer value with a container. That way I could create a series that starts at 1 and moves by 1 and selects those indices and reduces my number to this point count. So that's the way of reducing a system of numbers. And then in doing so, you're left with a lot of nulls, and there's two ways to correct the nulls in your data. When you do that, you're going to see that you end up with these nulls off the bat that are still in your data structure. The two ways to kind of erase those would be maybe to use the replacement items, but it puts a similar item and a coincident item in there. So I just made a little list of XYZ points to replace those nulls. Or you can use this node, which is clean tree. And if you take a look up in sets, it's one of the first nodes to use, so it must be important. Actually, it's not first there, it is first here. Clean tree. And if you're not seeing all these components, you want to go up to view and make sure you have on see obscure components, otherwise you're getting a smaller subset of Grasshopper up here in the icon tools. So those are two ways, and then you can always chase back those panels and see that I can affect those points by these sliders. And of course you have to keep your visual on if you want to see that. So if I take those points and I start playing with those parameters, you see that I can affect how many are chosen and how many are not chosen in those numbers in all four viewpoints. And then I can affect the points as to where I want all those called out points, those replacement null points to go, which would be this one. And then I maintain the data structure, and I actually use this data later on to do a little bit of fun work in the what I call the sandbox. So what was the next one I did? It's pretty simple. It was calling out points. So I used the same indices, and instead of taking those indices and choosing those ones, I've actually called them out, which is kind of like an addition to a minus, and you're left with the points here and the points here. And they end up producing the same list, which is pretty cool if you think about it. Just two different ways of coming about the same thing. This one being a call index, and this one being a replace index. And the scripts are just a little different that formulated these codes in C#. I sometimes just grab this as a list length, have it as a number for items like a reduce list. So you have a list of 22 items, and then you're choosing an integer value to reduce, and I have a seed that change that. So I can go back to here, and that's probably the best way to reduce items randomly. So you're reducing 15 items, you're reducing less items, and you can see it's affecting my geometry because it's tied to the playground script in the end. And we'll get to that in the end. But these scripts are available on GitHub. You can play around with them, and then the seed will change kind of where things jump and where they actually situate. I keep my seeds pretty high, even though you hardly need 1,000 count or 10,000 count to do that. The playground item is pretty simple. I just used the Entwine I talked about to maintain the data structures. So if you took a look at what was happening here, it's kind of fun. I have a panel tool that will maintain those different lists of points, 1, 2, 3, and keep them in different structures. So as I go down, you see all the points from the first one, all the points in the second, and there's actually just a few in the last one. So just something to think about if you're going to use entwine instead of merge. But since I'm keeping them in a data structure, a tree from these see fancy wires, once again you go up to display, you want to draw fancy wires. I do have icon on and I have full names. Then I can put a graph through another series, which is just a step from 3, 6, and 9. I can treat those as the segments of a polygon, 3, 6, and 9, and I can treat it as the radius of that polygon. So maintaining your data tree structure is smart. You can use the explode tree, kind of the reverse of what an entwine is, and then I used a scream gate, which I don't use too often, which allows me to choose gate 0, which would say choose the 3s, 3 segments, 3 radii to produce these piped triangles at the radius whatever I want. I can have a little function in here, but you see it's starting to slow down because I'm dealing in solids. I really don't go too much farther past curves in the solids because it just seems to slow the script a little bit. And once you get too complex in that, you might want to go back into the Rhino environment to do the piping. I can step up through the iteration on the gate to 1 gate, which will give me the second data structure, which obviously uses 6 radius, and the last one will jump over and use the 9 and 9 side segments. So that's it. Not too hard. A simple playground that you can get to know. And what we've done is we've covered everything in the GH Basic Curve 001 on the point cloud objects, point objects. And then we did everything on this script, which was point cloud objects. What we'll do now is we'll go into line and we'll start the GH Basic Curves line, and we'll go through as much as we can in Grasshopper to go from single line all the way through tangents to vertical to C-plane, which could be kind of fun. All right, that's about it. Thanks for watching.